So the first thing you need to know when you're working with logs and trying to use them, on the calculator, this button, down by the 7, right next to the 7, is the log button. The log button on your calculator presumes that you have a base of 10. It's a 10. Normally we have a different number there. But the calculator needs it to have a base of 10. So, based on that, we have to be able to change this. And part of it has to do with one of the properties of logs that you guys don't know yet, so don't panic about it. But this is the change of base rule. And that says, change of base rule says that if I have the log with a base b of a, that is equal to the log of a over the log of b. So that is where the base 10 comes into play, because now we can put this in the calculator. So the way I'm going to use that, if I have, for example, 3 to the x equals 12. My answer is not going to be a whole number. It's going to be between what two numbers? Two and 3, because 3 to the second is 9 and 3 to the third is 27. So it's going to be between 2 and 3. And we're not going to be able to get it to, a terminating decimal or anything like that. We're going to get it as close as we can. So what we need to do is rewrite it as a log. Which would be log base 3 of 12 equals x. And our calculator, I'm sure some can do a change of base without using this rule, but we don't have that on the calculators that we have. So we can't just put this in as the log of 12, because that would presume the log base 10 of 12. But what we need to do is rewrite it using this change of base rule. So log base 3 of 12 can be written as log of 12 over the log of 3. And there's a very important step in here, and I'll move that in just a second so you guys can write it down. When you put this in, so you're going to put the log of 12 divided by the log of 3. Can somebody tell me what's wrong with what I just typed in? Huh? I gotta close the parentheses. So if I go after 12, right now this is taking the log of parentheses 12 divided by log 3, which is going to throw off what I want to do. So I need to put in that second parentheses, whoops, in the wrong place. There we go. So log of 12, close the parentheses, log of 3, the second parentheses isn't as important, but we'll put it in there anyway. And we get 2.26, yada, yada, yada. And then we can also check and make sure that we're actually right by using the calculator once again. And we can do 3 to the power of, and see if I can fit this in here. If we push the second key and the negative key, right here, there's a little answer in blue. And so it brings up your answer on the screen. So 3 to this power. And because we didn't have to round anything off, we got exactly 12. So this part is how you solve, and then this part is how you can check. So we have x equals approximately 2.26. And that is how we solve using logarithms when we have an exponent that we don't know. If I have an exponent of x, this makes it an exponential equation. Do I want to start by changing this into a log? No, I do not. What do I need to do first? I'm going to subtract the 2. So I'm going to gradually unwrap this 3 to the x. So I've got 5 times 3 to the x equals 48. Then what? Can I multiply 5 and 3? No, because we always, in order of operations, you do exponents before you multiply, so you have to get rid of that multiplication first. I'm going to divide by 5. So I've got 3 to the x equals 48 divided by 5, which is 9.6. So we should get something very, very close to 2, because 3 to the second is 9, so we're at 9.6. So this is pretty close to 2, but it's not going to be exactly 2. So what do I need to do with it now? Turn it into a log. And what's it going to be as a log? Log base 3 of 9.6 equals x. And then how am I going to put that into my calculator? Very good. Log 9.6 divided by log 3. Sorry, we're running out of room. So log 9.6, close my parentheses, divided by log 3 equals 2.05, and I'll round that to 9. Make that our squiggly equal sign for approximately, and that is it.